Good day and welcome to Science E-Learning Academy. In today's tutorial video, we shall be solving a problem on motion in a cycle, and we are taking it from JAMB 1984, question number 26. Alright, let's get started. When a body is moving around a circle, it is performing a uniform circular motion if the speed is constant. If the speed is constant, we say that the body is performing uniform circular motion. And a body moving with uniform speed around a circle has an acceleration that is directed towards the center of the circle. And this is called centripetal acceleration. Centripetal acceleration is given as v squared over r, where this v is linear velocity. So as the object is moving around the circle, you notice that the linear velocity is changing as the body is moving. This is because the displacement is changing. So if we define centripetal acceleration, which is directed towards the center of the circle, as v squared upon r, then we can find the relationship between centripetal acceleration and the angular velocity, which we shall see shortly. So as the object is moving with a linear velocity around this circular parts, don't mind the drawing. So this is a circular part. So when the object is moving with linear velocity around a circular part, it's moving with an angle theta. So which we shall now define the angular velocity as the angle turned through divided by the time elapsed. So if we want to find the angular velocity here, we use theta over t, where this theta is in radians. For instance, now if we want to calculate the angular velocity for a cycle, so we have that angular velocity omega will be 2 pi upon t, where t is the period. So when we want to calculate the angular velocity at this point around circle, so we use 2 pi upon t. Alright, but in this problem we are solving, we are given the radius 0.02 meter. We are given the speed. This is a linear speed. If the speed of the particle is 0.88 meter per second, calculate the frequency. We are meant to calculate the frequency. So let's go back. We know that the relationship between linear velocity and angular velocity v is, v equals omega r. The relationship between linear velocity and angular velocity is v equals omega r. In this case, when we are not considering the direction, we can call this linear speed, call this angular speed. Alright, so if we now you know that omega is 2 pi upon t, and this t is period, which we know is the inverse of frequency. So we can say that omega is 2 pi f. So that we now have that v equals 2 pi fr. The linear speed is v equals 2 pi fr. And in this problem, we are meant to calculate the frequency in cycles per second. So we have now found a formula that will assist us, which will say that v equals 2 pi fr. So making f subject of the formula, we have that v is F is V upon 2 pi r. Make F subject of the formula, you have that F is V upon 2 pi r. So how did we go about it? We know that V equals 2 pi fr. So making F subject of the formula, you divide by 2 pi r. Divide both sides by 2 pi r. So that when this cancels, we are left with F, and F is 2 pi, F is V upon 2 pi r. That's fine. Alright, the next thing we do now is to substitute in the equation. So we now have that V is 0.88 meter per second, and this is 2 times pi is 3.142, and r given is 0.02. If we multiply 2 times 3.142 times 0.02 and divide it with this, what do we have? So we have 2 times 3.142 times 0.02. We have 0.12568. So, and when we divide 0.88 by that, we have 0.88 divided by 0.12568. We now have 7. This is in cycles per second. Of course, you know that frequency is in hertz, but it has another unit as cycles per second. Alright, so we now see that the answer now is, let's go back to our problem. We now have that the answer now is this. The answer is this, 7.0. So a particle moving in a circular orbit of radius 0.02 meter and has a speed 0.88 around the circle. The frequency in cycle per second is 7. If you've been blessed by this video, do well to share it with your learning colleagues, and don't forget to subscribe to our YouTube channel for more updates. Thank you and remain blessed.